Good morning, students. Today we are going to talk about remaining scheduling algorithms, that is priority, round robin, multi-level and multi-level feedback. Okay. In previous class we have studied about what is a CPU scheduling, and at the same time what are the various scheduling algorithms like FCFS and SJF, and some in scheduling criteria some definitions like turnaround time, average waiting time and burst time, some terminologies, all those things studied in previous class. In this class we are going to concentrate on remaining scheduling algorithms, that is priority and round robin. Okay. See here, whereas you know that FCFS and SJF. Okay, in FCFS, how the FCFS will work is, so first come first serve. That means the process which come first into the ready queue, that process is going to be executed by the processor. Whereas in the case of shortest job first, the process which have shortest burst time, that is less burst time, that process is going to be executed first. Okay, these two algorithms, scheduling algorithms, we have studied in previous class. In this class we are going to talk about priority scheduling. See what is meant by priority. Okay, the name itself, okay, we are going to assign one priority to each and every process. Okay, see for example here the scheduling is based on the priorities. Okay, for example assume that there are four processes P1, P2, P3, P4 in ready queue. Okay, all those four processes are in ready queue. Okay, we are going to assign one priority to each and every process. Okay, based on the priority we are going to execute the process. That means for example process P1 we are going to give one priority. Okay, next process P2, next one more priority, process P3 again one more priority, process P4, that is one more priority. Okay, process P1 will have priority 1. Okay, 1 means here highest priority. At that time process P1 is executed. For example process P2, okay, and then priority is 2. That means process P2 is executed like that. Okay, based on the priorities here we are going to execute the processes. Okay, the processes which are present in the ready queue, each and every process is associated with priority value. Based on the priority value the processes will move from ready state to the running state and executed by the processor. Okay, if in the case of any two processes will have same priority, okay, those processes are executed in the FCFS manner only. Okay, for example P1 will have priority 1, P2 will have priority 1 only. Okay, P1, P2 will have same priorities. If it is the case, which process is executed first is the order in which it comes to the ready queue. For example, process P1 will have one priority, process P2 also will have one priority. Okay, among these two, P2 will come into the ready queue first, means then only P2 will execute. Okay, otherwise if P1 will come into the ready queue, okay, that P1 will execute it. Okay, that means two processes with the same priority, which process is executed is the order in which they come to the ready queue, those order only it will execute. Okay, so here what will happen, for each and every process one priority is associated. Okay, here if you see in this one also we are going to calculate the average waiting time. Okay, so how we are going to calculate the average waiting time in FCFS and SJF, we know. In this one here again we have one extra column, that is priority. Okay, this processes P1, P2, P3, P4 is are in ready queue. So each and every process has a burst time, that P1 has 21, P2 has 3, P3 is 6, whereas P4 is 2. Okay, here in order to performing the priority scheduling algorithm we need one more value, that is priority. That means each and every process will associated with one priority. Process P1 will have priority 2, process P2 will have priority 1, process P3 will have priority 4, process P4 will have priority 1. Okay, here this is the process. For process P1 burst time is 21, priority is 2, P2 burst time is 3, priority is 1, like that. Okay, here we are going to take priority as one more column for each and every process. Okay, see in this priority, what how it is executed means based on the priority. Here if you see the priority, which process will have the highest priority. Okay, here highest priority means lowest in number is the highest priority. Okay, lowest in number is highest priority. It means here 1 means it is highest priority. Okay, then next 2 is next highest, 3 is next highest, 4 is next highest, like that. Okay, here which process is executed first? P2. Why? Because P2 is highest priority, so P2 is executed first. Okay, so P2 waiting time is 0. Okay, P2, for P2 how much time it will take? 3. Okay, so 0 plus 3, 3. So P2 is over. Then what about next, which process is executed? Next to priority 2, that means P1. Okay, so next P1 will execute. Okay, so what is the waiting burst time? 21. That is 3 plus 21 is 24. Okay, here it means P1 will starts its execution 3 milliseconds, it ends its execution 24 milliseconds. It means P1 is waiting at 3 milliseconds. Okay, if you see the average waiting time, so first P2, for P2 this we can say it is a Gantt chart. Okay, for P2 waiting time is 0, P1 waiting time is 3, that is 0 plus 3. Okay, up to this. Okay, next one is, next priority is 3. Next priority is 3 means P4. Next, which process is executed? P4. For P4, what is the burst time? 2, that is 24 plus 2 is 26. If you take P4 starting time is 24 milliseconds, ending time is 26 milliseconds. It means P4 process will wait until 24 milliseconds. So here plus 24. Again, finally, highest priority is 4, that is P3. So the burst time is 6. 26 plus 6 is 32. For the process P3, it starts its execution at 26 milliseconds and it ends with 32 milliseconds. It means P3 waiting time is 26. So plus 26. So average waiting time is for P2 0 waiting time 0, P1 waiting time 3, that is plus 3, P4 waiting time 24 plus 24, P3 plus 26. Okay, P3 waiting time is 26, so plus 26 by how many number of processes are there? P1, P2, P3, 4, P3, P4. So by 4. Okay, 13.25. Okay, so this is the average waiting time. Okay, so in this way we are going to calculate the average waiting time in priority scheduling algorithm. Okay, whereas next one is round robin. Okay, here the name itself says each and every process is executed in a round fashion. Okay, so in order to execute all the processes in previous one, we are going to assign the priority value. Here what will happen is for each and every process we are going to allocate one time slice or time quantum for execution. Okay, fixed time. Okay, for example, there are 4 processes are there: P1, P2, P3, P4. Of course, process P1 waiting time is from 20 seconds, 20 milliseconds. P2 is from 15, P3 is 10, P4 is 5. Okay, 20, 15, 10, 5. Totally 5 processes are there. Okay, what will happen is here we are going to assign one fixed time slot. Okay, that is assume that the fixed time slot is some 3. Okay, here what will happen? First the order is FCFS only. Okay, but based on the time slot. Okay, for example, 20, P1 20, 15, again 10, 5. Okay, these are the execution times of P1, P2, P3, P4. Okay, here for example, for each and every process we are going to assign one time quantum, that is 3 milliseconds. Here what will happen? First P1 process will execute 3 milliseconds of time. Okay, again P2 process will execute 3 milliseconds, P3 3 milliseconds, P4 3 milliseconds, again in round fashion. Okay, again P1. Actually, what is the waiting by execution time of P1? 20 milliseconds. Initially, how many milliseconds executed? 3 milliseconds only. Okay. So after completion of 3 milliseconds, 17 milliseconds is there. Okay. So in the round fashion, again it will come for P1. Among the 17, again 3 milliseconds. Why? Because each and every process we are going to allocate 3 milliseconds. Okay, in this way we are going to execute the each and every process in a round robin process. Okay, here what will happen is, once a process is executed for given time period, that process is preempted and other process execute for given time period. Okay, just now we have said that thing only. Okay, once the process is executed for given amount of time, okay, 3 milliseconds completed, next it will give chance to the other process. Okay, here switching is happens, P1 to P2, P2 to P3, P3 to P4, again P4 to P1, like that. Okay, so here that is based on the time quantum. Okay, previous one priority. Okay, right, here if you assume here totally 4 processes, same example only, P1 waiting time is, that is burst time is 21, P2, P3, P4. Okay, here assume that there is a time quantum of each and every process is 5. Okay, here different processes will not have different time quantums, time slice. Okay, each and every process will have fixed time slot only. Okay, here assume that fixed time slot is 5 milliseconds. Fixed time slot is 5 milliseconds. Okay, see here which process is executed first means, here the order is FCFS only, but based on the time quantum. Okay, first we have process P1. Okay, of course this execution time is 21 milliseconds. Initially how much time it will execute? 5 milliseconds. Initially how much time it executes? 5 milliseconds. Okay, here 5 milliseconds. Okay, among the 21, 5 milliseconds executed, remaining time will be withhold only. Okay, here what will happen is P2. Okay, actually for P2 how much time will have? 3 milliseconds, but what is the time quantum we have given? 5. Okay, we have given time quantum 5, but what is the actual execution time of the P2 is 3. So even in this case it will take only 3 milliseconds, no need to use 5 milliseconds. Why? Because even though I have given 5 milliseconds of time for P1, P2, P3, P4, okay, in the case of P2 it requires only 3 milliseconds. Okay, so first time only it will complete the execution. Okay, whereas P2 also it will require only 2 milliseconds. Okay, no need for 5 milliseconds. Of course our fixed time slot is 5 milliseconds, whereas here P4 needs only 2. Okay, there is no round for P4. P2 also 3, there is no round for P2, whereas P3, for P3 6 milliseconds are there for execution time for P3, but actually what is the fixed time slot? 5 milliseconds. Okay, so whereas in the if you comes to P3, it will execute 5 milliseconds one time, remaining 1 milliseconds is next round robin fashion. Okay, so here if you see the process P1, okay, the fixed time slot is 5 milliseconds. Okay, process P1, even though it has 21 milliseconds, the time slot is 5. That means 0 to 5 only, 0 to 5. Okay, 0 to 5. Okay, here 20 among the 21, 5 milliseconds are completed. Okay, next to P2. Okay, for P2 actually fixed time slot is 5, but it requires only 3. Okay, that's why 5 plus 3 is 8. 5 plus 3 is 8. Again P3, for process P3. Okay, for process P3 it requires actually 6. Okay, but time slot is 5. Okay, so 8 plus 5 is 13. 8 plus 5 is 13. Okay, so P1 remaining 1 milliseconds is there. Okay, so again in round robin fashion, next we have to execute P1 and P3. So for P4, okay, actually time slot is 5, but actual time slot is we have allocated 5, but it requires only 2. So for that one P4, 13 plus 2 is 15. 13 plus 2 is 15. Okay, then here in first round only P2 is completed, P4 is completed. Okay, again next what will happen? Again it will again go to the round robin fashion. Again in this 21 previously we have completed 5 milliseconds. Again it will execute 5 milliseconds, that is 5. That is here 5 milliseconds means P1, 15 plus 5 is 20. Okay, then P2 is not there, Again P3, for P3 initially 5 is over, remaining only 1 millisecond is there, so 20 plus 1 21. Okay, so again there is no P4, again come to the P1 only. Okay, 21, from 21 to 5, that is 26. Okay, 26 to 5, again 5, that is 31. Okay, remaining we have only 1. Okay, 31 plus 1 32. Okay, that means P1 will ends its execution at 32. Okay, P1 is ends its execution at 32. Okay, whereas P2 it completes its execution at 8 milliseconds. Okay, so here if you see like this, P1 completes its execution at 32 milliseconds. Okay, so it will wait for 31 milliseconds. Okay, this is the starting time, this is the ending time. Okay, again after P1, next coming to P3. P3 is completed its execution 21 milliseconds. Okay, waiting time is 20. P1 is over, P3 is over. Next P4. For P4, completion time is 15, starting time is 13. Okay, na? Whereas P2 completion time is 8 milliseconds, starting time is 5 milliseconds. Okay, same likewise previously we have calculated average waiting time. Na? Like this we are going to calculate the average waiting time. If we calculate the average waiting time, the waiting time is 11 milliseconds. Okay, how we are going to calculate? Okay, here P1 waiting time is 31. Okay, waiting time 31. Okay, so 31 plus, whereas P2, next P3 waiting time. P3 waiting time is 20. Next to P1 over, P3 over, next to P4. P4 waiting time is 13. P3 waiting time is P3 is over. Next P2 waiting time. Here P1 waiting time, P3 waiting time, P1 waiting time is 31, P3 20, P4 13, P3 over. Next P2, for P2 waiting time is 5. Okay, na? So calculating the waiting times by total number of processes 4, then we will get 11 milliseconds. Okay, in this way we are going to calculate. Here the thing is, here in this example, initially process P1 is executed 5 milliseconds. Process P1 is executed 5 milliseconds. Okay, 5 milliseconds executed. Next P2, P2 is executed 3 milliseconds only. Even though 5 milliseconds we have time, 3 milliseconds only it will execute. Okay, whereas P3 6 milliseconds. Among 6 milliseconds we have 5 initially we have P3 is executed 5 milliseconds, then remaining 1 millisecond will executed in next round robin fashion, whereas P4 is 2 milliseconds only. Okay, here process P1 is executed initially 5 and then 5, that is 21 minus 5, here 21 minus 5, here then next one, next to value minus 5, next value minus 5, here next value minus 5, finally 1, 31 plus 2. Like this we are going to calculate the this round robin fashion algorithm. Okay, next one is multi-level queue scheduling. Okay, here the basic CPU scheduling algorithms are only 4, that is FCFS, SJF, round robin, priority. Okay, this is one of the queue scheduling algorithm, that is multi-level queue scheduling algorithms. Okay, here this is one more class of scheduling algorithm has been created for a situation in which processes are easily classified into different groups. Okay, we are going to calculate the processes as a different groups, like no interactive processes or foreground processes or background processes. Okay, some processes are running foreground, that is interactive processes, or we can say some processes are running background, that is we can say batch processes. Okay, there are two types of processes we have. So in order to differentiate those two different types of classifications, we are going to use this multi-level queue scheduling algorithm. Okay, here the processes are system processes, are interactive process, interactive editing process, and batch process and student process. These are the different processes. Okay, why? Because some processes are running background, some processes are running foreground. Okay, we are going to divide the multiple levels. Okay, here multi-level queue scheduling means we have different levels. Okay, system processes will have some highest priority. Next highest priority is interactive process. Okay, the processes which is related to systems, those processes are executed first. Okay, next one is interactive process. Okay, next highest priority. Next one is interactive editing process. Next one is batch process, and next one is student process. Here student process will have the lowest priority. Okay, so here different processes will have different schedulings. Okay, so the processes which have the highest priority, those processes are executed first. Okay, so in this multi level queue scheduling, we have the processes are into different groups. Okay, like system, interactive waiting process, batch, and student. Okay, whereas next one is multiple processor scheduling. Okay, multiple processor scheduling. In this one, majorly when we are going to use multiple processor scheduling. Okay, so generally when multiple processes are available, then the scheduling gets more complicated. Okay, because no, there is more than one CPU which must be kept busy and in effective use all times. Okay, this is the case with multiple processes are available. Okay, here in this case we are going to use load sharing. Okay, load sharing revolves around balancing the load between the multiple process. Okay, in order to if you take if we have only one process, there is no problem. Okay, if you have multiple processes, what will happen? We are going to keep all the multiple processes always busy. Okay, in order to balance all those multiple processes, we are going to use the concept called as load sharing. Okay, why we are going to use load sharing? Load sharing is the concept. We are going to balance, by using the load sharing, we are going to balance the load between the multiple processes. Okay, so at the same time, multi-processor systems are maybe heterogeneous or homogeneous. Okay, here heterogeneous means different kinds of processors, CPUs, or homogeneous means all the same kinds of CPU. Okay, so we are going to use different kinds. Multiple processors means multiple CPUs means maybe different kinds, or all the same kinds of CPU. Okay, so what are the various approaches to multiple processor schedule? Okay, so whereas coming to various approaches, here majorly asymmetric multiprocessing, and next one is symmetric multiprocessing. Okay, one approach is to multiprocessor scheduling is asymmetric multiprocessing. In this one, what will happen is one processor is the master, controlling all the activities and running all kernel code, while the other runs on the user code. Okay, this approach is very simple and there is no need to share critical system data. Okay, this is one of the simple approach where in asymmetric multiprocessing. Okay, this is one of the approaches to multiprocessor scheduling. Next one is another approach is symmetric multiprocessing. Okay, we can say in this one what will happen is where each processor schedules its own job either from a common ready queue or from a separate ready queue for each process. Okay, so in this way this symmetric multiprocessing will works. Okay, these two are the major two approaches for multiple processor scheduling. Okay, so these are the concepts covered in CPU scheduling concept. Okay, so in this CPU scheduling concepts, mainly we are going to focus on the CPU scheduling algorithms, that is FCFS, first come first serve, SJF, shortest job first, round robin, priority. FCFS means first come first serve, process which come first, it will execute first only. SJF, the process which is shortest burst time, it is executes first. Okay, and next one is priority. Okay, based on the priority, the process will move from ready to running. Okay, whereas round robin, for each and every process we are going to give some fixed time slot. Okay, after executing the time slot, again it will go to the next process, again it will move in a round robin fashion. Okay, all these are the various scheduling algorithms. Okay.